Um, Good evening, everyone. By the way, welcome all of you to the webinar on Overtaking ADAS system. This is me, who is Suraj, speaking on the side. I believe my voice is audible to all of you, and we are joined by our delighted speaker. That would be Prasanna Patil. I think we still have 2 minutes to start ahead our webinar. Uh, I would like to have this 2 minutes utilized, that we can just know about each other and what interests you to take part in the webinar, or like any specific expectations do you have out of this webinar. Just let us know. By that way we could make this webinar more interactive and interesting for all of you guys, right? So and I'm really happy that you guys have joined from all over the places. I could see some names who I already know in the past of our courses. Quite happy, and thanks a lot everybody at Decibelites who have joined the program, and also welcome the guys who have joined newly and attending the program for the first time. So without just wasting much of our time here, we should start the course on time, webinar on time. Maybe we can have like a small 3-4 minutes of a delay. So I think within that time, let's sort of understand each other. What interests you to take part in this webinar, and if you are working in any of these systems such as ADAS, just share your story. I think with all of that, we get to know you, and if you have any specific objective that you are attending this webinar, just do let us know. By that way, as a speaker, and for me, from my side, I'll also know what is your expectations are. We try to converge the whole discussions towards that area and try to make it as useful as possible. Yep. So kindly use your chat box. We're waiting for your inputs. So quickly take over an opportunity to brief about, maybe just brief about you, and if you are, what is your interest to take part in this webinar. And if you worked on any of the systems, just let us know, so that we can make this whole webinar interesting and useful for all of you. Okay, so I'm just waiting for some of your chat boxes to join in. Guys, you can make use of it. Let us know. That makes it more interesting to carry on the whole webinar. We're waiting for your chats to be coming in there. Okay, anybody dropping in the messages? We're waiting for it. Okay, all right, so just personal. Right, so over to you, Prasanna. So I think, yeah, I can hear. I think you're able to hear you're able to unmute. Yeah, I'm not crazy about ADAS without driver. Interesting. I think let's start our journey with the driver, in L1. So, and then we can definitely start without a driver down the line. We still don't see, major implementation in India on ADAS, at least at a smaller system. So like, with the vehicles between certain price range. So let's start with that. We'll surely look into without drivers and maybe level 4, level 5 autonomy. I'm Pranay, fourth year RIT Bangalore. Road safety always interested me. Amazing. That's really good to know. Himanshu have reviewed the systems at Mercedes-Benz Advanced Safety Systems. Awesome. Glad to have you, Himanshu. Good to know you too. Guys, you can just drop the messages in general. You don't need to text me privately or anything. So, okay, so just so we have I worked as a brake analyst in Formula team at our college. Graduated this year. Interesting. Biology, doing masters in RI. Very interested in ADAS. Interesting biology. I'm on the part of Decibel's team. Awesome, vehicle dynamics. Fantastic, guys. I think, very glad to know and quite happy that, you guys have joined from all over the places. We have seen like all the participants, like, crowded across the whole country. And it's a very privileged to host you all today. By the way, let's get started with our webinar without wasting much of our time. So as you already know, if you're part of Decibels, have been a part of programs in Decibels, that we don't kill much of our time introducing ourselves, because you would know it by the quality of teaching, and that's what we believe in, than just putting a 10 slides of presentation, making you bored that hey, this is what Decibels does. Decibels does something which is useful for students and which helps them to create a career. We're trying to uplift the whole quality of education which is available in India by having courses which are more practical, which are more industry oriented, which makes people to start their dream careers. So that's what we do in a simplicity. And apart from it, Decibels also not a training company just. We also provide engineering solutions to various startups in India and also across parts in Sweden. It means we do consulting and we do work with industries, and we have over 20 engineers at Decibels to work in various components of the automotive systems. So that's what we do overall at Decibels. So let me not just drag a bit of it, and let's start ahead with the webinar. And we have Prasanna here today to deliver this webinar. Um, so why this webinar, and what is our interest about ADAS? Because anything in automotive is an interest for me as a founder of the company. And definitely it is all bunched by amazing people like Prasanna who have worked on these systems. Okay, that just connects us all in over. So the second point is, when we love automotive, so the meaning of all that is like, we want to contribute back into the society as much as possible by creating amazing systems that can save lives. So talking about it, Prasanna will address that, but I would just give a one-liner, which is said about in the email, that India loses about 3% of the GDP. That's goddamn about 50,000 crores, which we lose every year just because of road accidents. I know we can't stop all of that because our drivers are also crazy enough to not to drive in the right way. But at least, like, we can use technology, we can enable the tech into the automotive and that would actually solve some of the problems which is causing road accidents. That's the motive and that's the internal passion for us at Decibels to bring things into reality. So that's with that interest to make things happen. We've been planning to organize this webinar, and definitely things doesn't just stop at webinar. So things always go ahead of webinar, and where we will be able to make you to build a model of that overtaking system, and make you get an expert, and possibly you could build one of the system, or at least you could join companies like Bosch, Conti, Delphi, Siemens, anything of them who makes this ADAS, and you can be a part of the team, and you can contribute as an engineer to an ecosystem, right? So that's what we can do as an engineers to make things work in a better way for the whole world and the whole country itself. So the challenge is very big as such. What we trying to, what we're failing in making the whole road safety system to work. But as we can't fix everything, it's a big thing, and we could do things which can possibly bring the impactful change. And I think with this webinar, we're just starting out, system level knowledge at ADAS, and then we will gradually have very deeper knowledge level courses. And as you always trust, Decibels courses are not GAN. It's about practically making things to work and learn in depth about all these systems. So with all of that interest down the line, and overall vision of having engineers pumped into an right ecosystem to contribute. So we have this webinar, and to deliver this, we have Prasanna. So Prasanna studied B in mechanical engineering and masters in Hans University of Applied Sciences and Automotive Engineering. So why Prasanna, by the way, for this webinar? So Prasanna has worked extensively on ADAS system during his master's at Hans University. So he has built and simulated systems and done the studies, extensively worked on that, and that's one of the area. The second is very passionate about automotive, like all of us, right? So those are the two things which actually matches to invite Prasanna today to deliver this webinar as a part of it. So with that interest, without killing much of the time, let me hand over the session to Prasanna. Hey Prasanna, welcome to the webinar.
Hello, Suraj. Hello, everyone. Thanks for the introduction.
Thanks very much, Prasanna. Prasanna, is it audible to you? You're able to unmute the screen?
Yeah, it's audible for me. I can listen.
Okay. Uh, you're able to unmute also, right?
Yeah, I can do that.
Perfect. Awesome. So then I'll hand over the session to you. I'll mute myself and here on over to you to have an amazing interactions with the audience. And thank you everybody for joining in. And I'll be there till the end of the session. Hold on and enjoy the session. Thank you very much. Over to you, Prasanna.
Thank you, Suraj.
Thank you.
Hi, guys. Hello, everyone. Welcome to the webinar. So today we are going to have a webinar on overtaking ADAS systems. So already Suraj has given an introduction. So no need too much dig into it. So I'll just quickly move towards my introduction. Yeah, as Suraj already has said, I have done the BA in mechanical in India and masters in automotive systems engineering Netherlands. So basically, I'm expertise in powertrains, vehicle dynamics, intelligent mobility, specifically ADAS, and the control systems. So I have professional experience working in several companies. So I worked as a research and development engineer. It's a MTT tractors, multi-tool tractors in the Netherlands, and also I worked in a company called Keep Electric. It's an electric company in Germany, and I did my master thesis in that company. And right now I'm working in the consultant engineering decibels lab private limited. Thank you.
Prasanna, I think the audio is a little low. Yeah, would you mind maybe speaking a little bit louder, or maybe earphones closer to you?
Yeah, sure. Thank you for informing me. Hi guys, now it's audible, I guess. Yeah, please type as if it's audible clearly. Hello. Hello, Suraj. I think I don't know some issues with my microphone. Give me a second.
Okay, you can maybe switch over to your phone. I can just add you an access into that. Sorry for the issue, guys. Just trying to fix it.
Hello, Suraj. Can you give me access to my mobile?
Yes, Prasanna. What's the name of the audience who joined in?
It's Prasanna Patil.
Okay. Yeah. I have done that. Please do check once.
Yeah, I can hear it now.
Awesome. I think it sounds pretty clear right now.
Yeah, perfect. Yeah, sorry for the inconvenience, guys.
Yeah, that's all right. We're good to go ahead. Thank you.
Yeah. Hi guys. Let's move towards the introduction. Let's discuss about today's agenda. So basically, today's webinar divided into 4 sections. One is introduction, overtaking systems, and like how the system works, and like what is the logic behind it, and the advantages of the overtaking assist systems, and the conclusion, and at last open for question and answers. So basically, first question everyone says, why overtaking ADAS? So why we need to do that? As Suraj already mentioned, there are like many accidents, and many people are dying throughout the world just because of the accidents. And as you can see from these slides, where it shows clearly, and this data is regarding the Indian market. So the every day, because of overtaking, the statistics shows is like 26,829 people have died. So there might be other reasons where people might have died, but the overtaking is the major one where the people are losing their lives. So this is one of the difficult system, and it's one of the useful system for the drivers. It helps them to move the or to make the overtake easily without collision or something like. So that's the reason why overtaking system is the most important ADAS systems, like we can say, because of course, like from the statistics, the many lives can be saved with the help of the overtaking system assist. So this is the main motivation why we need to work or develop the overtaking assist system. So next one. So before discussing about the overtaking system, so autonomous levels. So some people might be aware of the autonomous levels of the cars, and some people might not. So basically, there are 6 type of autonomous level, which you can see from the slides, from level 0 to level 5. So which means level 0 is just like no systems in the car, like EBD, electronic brake distribution, or like automatic emergency braking. There is nothing. It's a just car which was in like around like 1980s or 1990s. So in the level one, there were like slowly one of the systems included. For example, cruise control, or it might be a blind spot you can consider, or it might be a ill assist control. But in the level one, at a time there will be only one ADAS systems will be working, not both the systems. And in the level two, you can see that even you can control the vehicle's acceleration in longitudinal direction, as well as lateral direction, which is steering. So it's a multiple of the ADAS systems. So you can see the slides where they mentioned the lane centering and adaptive cruise control. So this is the level 2 autonomous. And about the level 3 and level 4 autonomous, it's like people will be, I mean, driver will be present in the car. You need to just monitor the vehicle behavior. If in case if it goes wrong, or if it's not working as expected, so they can take over the control, and he'll be having the control. He can take over it, and he can control the car. So in order to avoid the collisions or whatever the damage is going to happen. So that is the level 3 and level 4. So, and in the level 5, there is no driver at all. Everything will be done by its own. Maybe you might be aware of the Tesla's autopiloted car, which is like completely autonomous, where there is no driver, and it drives across those cities and countryside, everywhere. It might be in the market area, or it might be the highways. So basically, that is like it's a self-driving, where there will be no driver at all. So these are the different types of autonomous levels, which which they present in the automotive industries. So next, the question arises like, okay, so overtaking assist system. So which level of which level it is? Like, is it level 1 or level 2 or level 3? So guys, can you guess the? I mean, can you tell me the which level of autonomous system is the overtaking system? Please, you can type in the chat box. Yeah, I can see from the chat box that like people are I mean they're guessing the answers. It's like some are telling level 4 or level 2 or level 3. But guys, it's not level 4 or level 3. It's just a level 1, because the overtaking assist, what is doing, it's just like assisting the driver to make the safe overtaking. So it does not making its own steering to make the overtake, or to uh, change the angle and change the lane and move on. So what it does is just like it will give input to the driver whether he can overtake it or not. So if he overtakes, is it safe overtake or not? Or if he is like if he overtakes, or he might collide to the next vehicles which is coming in the opposite lane, or like which is already in the next lane. So what is overtake assist? So the word assist means the where the it helps the driver to make the safe overtaking with some maybe with some like green light in the dashboards, so that he can just overtake without any collision, so it will be safe. So as I mentioned in the previous slides, so autonomous level 1 is nothing but it's like it's a one ADAS system working at a one time. So here like overtaking assist system is level 1 assist systems. I hope you guys got it. So yeah, next moving to about the autonomous sensors. So as we discuss about the autonomous vehicles, so how does the what all sensors will be included. So how does the sensors will be placed in the vehicle, and like what are the types of the sensors. So yeah, as you can see there in this slide, uh, the the black mark which is you can see in the slide, it's a car. Basically this image is from the official website of the Tesla autopilot car. They have placed the different types of sensors in that autopilot car at the present. So here you can see that there are like n number of sensors, which is like camera is there, then ultrasonic sensors are there, radar is there. So everything has a certain range, right? So for example, you can see that like there are two types of cameras, main forward camera as well as narrow forward camera. So the two cameras have different range. One is 150 meters and one is like 250 meters. So the why there is like different types of range for the different camera. Basically the reason is like the different cameras or multiple sensors are used for different reasons. Might be as you can see from this image that narrow forward sensors, the width is less compared to the main forward camera, where the width is more. So in this way you can compare to the wide forward camera or like rear view camera or like side camera. Yeah, so basically this is the reason why there are multiple sensors in the cars. So each sensor plays an important role in order to make the vehicle autonomous. So let's discuss about the what all the like how it looks with let's with respect to previous slide. This is how the different types of sensors are placed in the hand, which helps for the vehicle in order to make the autonomous. For example, you can see that purple line is the radar and lidar, and the light blue is the camera, and orange is the ultrasound. So there are like multiple purple color you can the images you can see in this slide. uh, as I said in the previous slide, the width or the amount of range, it changes with respect to different sensors. So as I mentioned in this slide, you can see that for adaptive cruise control the range is high and the width is less. So the reason being is that, as you know, the cruise control just follows the car which is going in front ahead. So for that they need to maintain distance. So definitely they need a long range. And for emergency braking or pedestrian detection or collision avoidance, so sometimes suddenly people can come in front of you or anything can come. So in that case, like the range is if it's less it's fine, no need to it should be more range. But the width, so it should be big enough so that it can detect the uh, whatever the things coming in front of the car. So this is how the sensors or the cameras which is implemented in reality in the cars. So they are like which is from this you can see that like all the 360-degree of the car is covered with the sensors. So it might be a blind spot or it might be a red collision warning, anything. So all the sensors has different roles to play in the cars. So this is the reason why there are a number of sensors are used in the car. So yeah, this is one of the real image, which is the Tesla S model, where they have implemented the radar and lidar in the cars. So you might be having questions like why they are placed on top, like why not the below on the hood or something like that. So as I mentioned, every sensor has the different roles. So according to the specifications and requirements, it will be placed on the cars. So next comes here technology. So how does this autonomous vehicles works? So like based on what it works, like how the communication happens. So is it something it goes to the server, come back, or is it direct between the cars? So maybe you might guys having some knowledge about this, I guess. So if anyone knows like what type of communications models it will be used, so please type in the chat box so that we can discuss on that. Hello, I hope you guys are listening. Yeah, I can see the answers. Yeah, I can see some of the answers over here. That's good. Some people, I mean, many of them know about those. So basically, there are like four types of communications which are currently happening in the autonomous vehicles. One is Wi-Fi, and one is the Bluetooth, and one is the GPS, and one is the WAN. So Wi-Fi, everyone knows it's like wireless signals. So each cars will be having the modules already fitted in the cars. So they made an algorithm in such a way that they directly connect with the cars and they talk with the cars. As you can see from this slide image, that like every car will be having certain range of communications. It might be Wi-Fi, it might be Bluetooth or GPS or WAN. So based on that range, when the other cars or some other the cars which is in the same lane or some other lane, whatever, which comes in that range, they start communicating. What does this exactly communicating means? So communicating means when it comes inside the range, they start exchanging the other vehicles data like velocity, like what type of car it is. It is like 4-wheel or 6-wheel, and what is the is it like driverless car, like all the details, like what type of is it, does it like it's having a brake distribution or like everything, each and every single detail will be transferred into the data, and those data will be storing inside the modules, and it will be like helped in the for future if that same car it come in contact with the, again in future. So this is how it's working in the reality right now. As I mentioned, the Tesla's autopilot car, it's working exactly same as this. So you might be getting confused, like Wi-Fi and Bluetooth work same. So like when they have to use Wi-Fi and when they have to use Bluetooth, that's again complete different story. So it depends on completely manufacturers. As compared to Bluetooth, the Wi-Fi range is more. So in the cars, like initially stage, they used to consider Bluetooth as the communication model, but at the present stage, they are using Wi-Fi because, of course, the range is more. So more range, so better system, ADAS systems works, and then there is the better safety. So again, next comes the GPS. So everyone knows about GPS. So whatever the data is there, it will send to the Google, I mean satellite. Based on the satellite, the data will be exchanged between the cars. So this is the big process compared to Wi-Fi and Bluetooth, of course. But the safety here is more because Wi-Fi sometimes, if in case if anything happens to the like inside the car module or something like that, so it might affect to the everything. But if the car is directly connected to the like something called master, which is a satellite, so it can handle the situations and it can control the cars if in case anything goes wrong. So next comes VANET. So what is VANET? VANET is nothing but it's a vehicle ad hoc network. So V stands for vehicle, A stands for ad hoc, and NET stands for network. So what is this? So basically, right now, all the three what we discussed is just between the cars, and GPS is between the satellite, which is placed somewhere in the like somewhere in the sky, and it's connecting. So basically VANET, what it does is like VANET is nothing but they try to, it's a vehicle to vehicle communication and vehicle to infrastructure communications. So what does vehicle to infrastructure means? So basically within like certain kilometers, let's say like 10 kilometers or 50 kilometers, 100 kilometers, whatever it is, they'll be having certain one module where they will be connecting to the vehicles. So basically one vehicle will be directly connected to that module, and with help of that model it will be the data will be transferred between the other cars. And if the car moves to the some next place or something like that, again they will be having a one model, and the model which is having previous place and the model which at the present place, they both will be again communicating. So basically it's like a chain system. So because of this, like the VANET will be like in the, it's actually it's a future technology where the cars will be communication, and some of the like even USA they have implemented already, but within the very small range, it's not like huge range. And of course, like to implement in the every street, I mean with certain range and throughout the city means it will be absolutely difficult. So yeah, it is the future system. But yeah, this is how it works. The advantage of the VANET is it works towards the vehicle to infrastructure as well, and vehicle to vehicle communication. That's the best thing about the VANET. So these are the different types of communications module, which like the communication between the vehicles will take place in the autonomous vehicles. So next moving, like what are the different types of ADAS we have? Like as we as we have seen the overview of the sensors placed in the cars. So like as I said earlier, so different sensors has the different types of different roles in the making the ADAS systems. So as you see the like different sensors which I explained earlier. So can you guess like for example lidar, or for example camera or ultrasound, as you can see from the slide, its range and its like width. Can you guess like some of the ADAS systems which I mean which sensor will be used for the which ADAS systems? So please type in the chat box so that we can have a chat discuss on it. Yeah, Robin, it's correct. LiDAR is for distance sensing. And can you guess like for what ADAS systems it can be used? Yeah, I mean, I'm getting the answer like what is the role of the sensors, but I want to know what sensors will be used for the ADAS systems. Yeah, when I can see lane change assistance, correct, cruise control. Yeah, yeah, guys, it's exactly the correct whatever people are discussing. So yeah, I can see from these slides, right? Like so the park assist, of course, like we need a like just a sense ultrasound sensors. So the range will be small and the width will be more. And there are multiple systems. For example, you can see the Overtake Assist as well, lane change assist as well, and adaptive cruise control, of course, which will be having the long range, and then blind spot detection. So these are the different types of ADAS systems which they are working in the industries with respect to the sensors. That's the reason why the these sensors are plays a major role in the autonomous cars. Then again there will be multiple questions like what if the sensor fails and all. That's actually a completely different story. There like again it comes to functional safety and all. So let's not discuss about that. So yeah, these are the different types of ADAS systems which they are already current into the market. You can see the upcoming the cars. It might be like even in India you can see like mini Toyota or like any car you can take. There will be like always park assist, and the cruise control has nowadays become common. And there is something called hill descent. So yeah, these are the different types of ADAS systems. Maybe in future there will be like many like overtake assist might come, or there are so many researches going on the ADAS systems. Hey guys, so let's move to the next slide. So let's move to the topic like overtaking systems. So what is overtaking system? So yeah, and how it does. So you can this is the image taken from the UK government. So as you can see from this image slide that there are two lines, one is red and one is green. So if he follows the red line, definitely the truck guy will hit the car and then there will be a collision. But if he follows the green line, then definitely it will be a smooth overtaking and it will and he'll be safe. So now the question arises like how it can be done. So what are the procedures? So before going that, like let's discuss about the what are the steps of the overtaking systems. So yeah, phase one, the driver, I mean the overtaking car will be approaching to the lead car. In this case, the truck is the lead car, and the green color car is the overtaking car. So and you can see that there will be like a certain always when the car is approaching to the lead car, always there should be a certain distance of comfort. So it should be not like just behind the lead car. So that if you turn the steering, then definitely it will crash to the lead car. So there will be certain tolerance you can say or something distance you can say. And then again the next is like phase two. As soon as the whatever the specified distance or whatever the comfort zone will be there, if that car reaches to that zone, then the second phase will be activated, that is the steering away. So what the driver turns his steering and he moves. And the phase three is like he'll coming back to the same lane. So here again question come if sorry the phase three is like the distance between the overtaking car and the lead car, which is the lateral distance. So it should be not like there is a certain distance between them. It should be not like just next to the lead car he will overtake. So it will be a problem for the lead car if he makes any small errors in the steering angle, something like that. It might cause accidents. So again, there should be some comfort zone, like what should be the lateral distance between these two cars. Then again, if in order to maintain distance, then again it should be like steering angle, how much steering angle it should be. So yeah, this is the process. That's like again it will go deep into that. We'll discuss about that. And then next phase four is the returning phase, where the car returns to its original lane. So again, in this case, the comfort zone is there. As you can see this from this slide, is that if he follows the green light, then it will definitely overtake easily and it will be safe. So at the in front of the truck, So the distance between the green line and the truck is more than the red line. So he'll be safe. He follows the red line, so he will crash into the truck. So that's why the phase 4, like returning stage, that's also important, and there should be some comfort zone. So basically, these are the 4 steps of overtaking. Usually, like even a V does it. This is a common thing. So, but yeah, the important reason or like the reason behind the slide is like for everything there should be some comfort zone, and there should be like some distance in order to maintain that. So the question arises like first as soon as like okay, which all surrounding vehicles to consider while modeling. So in reality, of course, there will be like n number of situations you can like. There are some basic situation to like complicated scenarios, but of course, modeling will be having certain assumptions or certain limitations because, as you know, modeling and reality are never will be same. So there will be some marginal error. So basically, like so there will be like we should like decide like what types of what scenarios we are considering and what type of model we are going to consider, what are the vehicles we are going to consider. As again, and the next question is like how system the complex is. So yeah, as I mentioned, like it can be done like even like some of the guys I mentioned, it's autonomous level 4 vehicles. Definitely, it can be make autonomous level 4. But again, like there are multiple ADAS systems comes into picture. One is overtake, then one is the lane assist, then one is the steering control. So yeah, when you combine all the ADAS systems, and then it will become autonomous level 4. But yeah, so when you start the modeling, always you should start with the basic and which is a simple, because at like suddenly you can't model everything and you can't get the results. So now the question like yeah, what type of model should be considered? So guys, can you guess like some of the scenarios for the basic modeling? What else is scenario should consider? Like for example, we should consider all the surrounding vehicles or only vehicles between the same line. So please type in a chat box so that we can discuss that. Only 2 vehicles in same lane, Ruben. Yeah, vehicle in the specific range or the lane. Yes. Hey guys, so basically, there will be always 2 types of roads in like throughout the world, as like even you people know, everyone knows. So the first is the first type of situation what we consider is like the vehicles traveling in the same directions and the opposite direction as well. So here you can see that there are 4 vehicles, which is C1, C2, C3, and C4, where C2 is the overtaking vehicle. So this vehicle has to take care of the vehicle which is coming behind, that is C1 vehicle, and also it should take care of the vehicle C3 to in order to overtake that one. So if driver, I mean the system wants to make safe overtaking, it should consider the vehicle which is coming in the opposite direction, that is C4. So basically, in this type of situation, we should consider the in these four vehicles, which plays an important role. So again, the one more type of the vehicle is the vehicles which are traveling the same direction, but there are like 4 lanes. I mean, there are n number of lanes, 1, 2, 3, or 4, whatever. So in this case, like again, yeah, as you can see that like blue vehicle which tries to move to its left lane, but in order to move that, like you never know the driver which is in the B lane, he might come to the C lane. So in that case, he might collide to the car. So then again the vehicle C, which is just behind the car, so you might come with like some speed, and you might hit to the cars. So this is other type of situations where we are considered a number of vehicles. But as you know, like apart from India, everywhere there will be like certain traffic rules. So always they should overtake. In India also we should overtake always from the right side, not from the left side, right? So that's one of the advantage for us to model the overtake systems. So assuming that like always cars overtake in like right direction if we consider India, and its left direction if we consider the Europe or US. So that's the advantage for us while modeling the systems. So yeah, these are 2 types of different types of systems or scenarios which we can consider. And yeah, and the logic, as I mentioned, like we should consider different types of cars in order to make the logic. So how to overtake them, then how to get the time to collision. So what is the time to collision if its speed is like around 100 kmph or 150 kmph, because we cannot limit the speed, right? So it depends on the people or a driver. Okay. Next, yeah. So now about the sensors. As you can see that this is the like three sensor data. How the data will be collected when the vehicles will be passing with the lead vehicle, which is black vehicle in this slide. So initially you can see that sensor data of the phase one approaching, where that if you observe the angle, the only left side of the lead car, which is black car, is collected. So that of course the yellow color car is just like left side. I mean it's behind and it's like left towards the right car, black car. Sorry. So well, as soon as it moves, so the data will be keep on collecting, and you can see that like when it moves to the phase three passing vehicle, where the lateral distance data will be collected. And if you move to the steering away systems, where the diagonal and the I mean it's like to the left side and towards the front and back, the two types of data will be collected here. So again, if you returning for, which is the phase four, so again, the distance, relative distance between the front vehicle and the back vehicle, the data will be collected. So based on this research, what we can make or what we can conclude is that we can fix certain amount of like comfort zone as we discussed. So okay, suppose if the vehicle between the overtaking car and the lead car is around like some 10 meters, it can move toward, it can steer the vehicle and it can move. So this is the why the sensors plays a very important role. And researchers is just in the modeling we can see that later stage there will be a certain number of parameters where there will be there certain number of digits. So why we should consider that one? So yeah, in that case the sensor plays important role. So everything is parameter decided based on the research. So guys, can you guess me the what of the if types of sensors used for the overtaking assistance systems? Please type in the box. You can see lidar, camera, ultrasonic sensors. Yeah, lidar, camera, lane changes is no service. Actually, we're discussing about the types of sensors, not the ADAS systems, speed and RPM sensors. Okay, so basically in the overtaking assist systems, we can use only three types of sensors, which is lidar, radar, and camera. Because like yeah, of course, lidar and radar is for the ranging sensors, and camera is like better sensor compared to radar and lidar. Everything can be visible and can make the whatever type of control we can do, we can make it with the help of the camera. So yeah, basically then radar and the radar are the same sensors, but there are different type of working. The lidar is the actually like light sensor where the light rays will be emitted, and distance between relative distance between the lead vehicle and the overtaking car will be calculated with help of the light sensing. But the radar is like different. It sends the radio waves. So both the lidar and the radar has like different advantages and disadvantages. That is not the today's topic, so we'll not dig into deep yet. Yeah, so basically these are the three type of sensors which will be used for the overtaking assist systems. So guys, so yeah, this is the model-based design which we have already developed at the Decibels lab. So yeah, so basically the inputs for the systems are like relative distance between the overtake car and the opposite lane car, which is the lane coming opposite in the next lane in the opposite direction which is coming, and of course overtaking car velocity and the lead car velocity means like the car which is in front of the overtaking car, and the relative distance between the overtake car and the lead car. So in this model, what we're basically doing is like, okay, we are going to calculate what is the time to collision and when to make the steering input and how to make the steering input and how to consider, as I mentioned, like lateral distance between the overtaking car and the lead car. So where does the controller plays an important role in that situation. So like, yeah, all the parameters comes in, like how to do that, everything does the controller. And next, the driver response. As I mentioned, it's like overtaking assist system. So the system controller calculates like, okay, well it says like whether it's a safe distance or it's like it's time to overtake or it's not. So basically just imagine you can like actually you can just display a green light or red light in the dashboard. If the overtaking assist systems use a green light, then it's safe to overtake, and if it's red light, it's not safe to overtake. So seeing that, the driver will take the response and he'll steer away. So that is the model which is already developed the decibels. So yeah, basically you can learn it at the next level course. So guys, this is a small video. This is I developed at my during my masters, where I did the overtaking assist system control, considering the first scenario where the cars in the same lane and the cars coming in the opposite direction in the next lane. So this car has to, overtaking car has to consider the situation of the lead car and also the car which is coming in the next lane in the opposite direction. So the actually this is done in the software called Prescan, where we can develop the controller in the MATLAB, and we can integrate it with the Prescan software, and you can see the visual whether the whatever the controller we have done is overtaking safe or not. So yeah, I'll just play through the video. You can have a look on that. So if you're observing, the driver stays away, and then it comes to its original lane before the opposite car comes and collides it. So yeah, this is the safe overtaking in this system. The overtaking car, as I mentioned, it considered the car going in the car in the same direction, and it's like when it comes to the closely, it overtakes, and then again it moves back to the next lane, and within the time span of the opposite lane car which is coming. So yeah, here we have considered like all the velocities of the four cars as well as the related distance and everything. So yeah, it's a controller which we developed, and it is implemented in the pre-scan to see the visual. So guys, we all discussed about the overtaking systems and what is systems, how it works, and what are the different steps. So just like some questions like, can you guys guess what are the advantages? I mean, how it will use to the people, society, or whatever. So just type in the chat box some of the advantages which you might be got to know from this webinar, something like that. Sanjay, safer road, yes. Especially fewer accidents, prevent less accidents, prevent crash. Hey guys, so yeah, of course, to avoid the accident only we are developing the overtake assist systems. That's absolutely true. So here are some of the advantages, which is of course safe overtaking, and it helps the driver, which means like it will reduce the effort of the driver to steer, and like to get confusion in mind when to overtake, when to not overtake. So basically it comforts the driver to overtake, and of course prevents the accident, and it saves the time. The why the saves time, it's like because like when you're in the driver's seat, you need to think like, okay, when to overtake and when to not overtake. Of course they will lose some around like 5 to 10 seconds to think and to make a decision, but if you have a system, definitely it will like you will save those like 5 to 10 seconds, of course, which is very very important during the driving time. And yeah, there will be no environmental damage with the wrong overtaking, or maybe with the more steering angle or less steering angle, something like that. And of course the overtaking assist, like it improves the accuracy of the overtaking, where there will be no damages and it will be safe overtaking. So yeah, these are some of the advantages, and there will be many more, of course. So these are some advantages which we have listed here. Yeah, so conclusion. So what is the conclusion of this overtaking systems? So basically this reduces the impact on society and environment, where there will be like no damages to the environment, and there will be no accidents. So so directly the impact on society and environment will be reduced. So driver errors to cause accidents is reduced. So as I mentioned, the driver did not to think about like within how much, I mean, when to overtake, when to start overtake, or when to take decisions. So in that case, if he does a small error with the speed of 100 kmph, even if it's like small steering angle, definitely will crash somewhere, and it will cause a huge damage to the society as well as the cars or like environment, whatever. So this is also an important role of how the overtaking assist systems help. And of course, the loss of lives are reduced with help of the overtaking systems. So yeah, basically these are the three main conclusions which we can draw back from the overtaking assist systems. Hey guys, yeah, thank you. This was about all the overtaking systems. So yeah, we can have a question and answers. Or I can see there are many question and answers regarding this. Hello, Suraj, you there?
Yes, Prasanna. I'm here. I hope it's audible. I have some background noise because there's an amazing amount of rain coming. So sorry about it if you're able to hear some background noise. I think amazing. That's a fantastic overview to understand certain complexities of the system and also other components that is required as a part of it. As I always know, work in the industry, it's a very big thing. Maybe a company will take like 3 years to develop the ADAS system, possibly. So I think, yeah, it's just an overview that we're able to bring it in. But I think it was very crisp as an overall and very easy to understand as a whole perspective because of your experience, which you have worked in the industry as a part of it and also like built products and that. I think let's take up some of the questions here. There are some questions which is very interesting you put across.
Yeah.
Yeah,
So,
over to you, Prasanna. Yeah.
so guys, before like discussing about the question, so one thing I want to know about you people is like modeling can be done in a simple way to the extensive difficult way. As Suraj mentioned, they take like years together to make a model. But basically, yeah, you people know that how the model we started is like just considering the basic steps, like baby steps we'll take one by one by one. So of course, whatever while modeling, we'll be having some assumptions and limitations, and then only we can start. So because the why I said is like I got a question from, I can see the comment from a person called Krishna Pai. Is like how can the systems be configured to work in cities like Bengaluru and Mumbai? Yeah, because Krishna, like as I mentioned before, like we are implementing such ADAS systems into the car. Before the all the drivers should follow the rules. So they should be always like right overtaking, okay, not left overtaking. If the people are taking left overtaking, then none of the systems can help. Yeah, so it's the why I said it's not difficult to model in Bangalore, Mumbai cities. It's just like that. Some of the driver rules also helps to make the systems right. So just you can't make a system like considering okay you can do or take left or right. No, that'll be not happening. So yeah, next Pranay Kitni, how likely the system will work in Indian road conditions? Yeah, definitely. These systems will work definitely in the highways. Of course, not in the cities, and we don't need a overtaking assist system in the inside the cities because of course the speeds will be less than 50 or 50 kmph, and because there will be more cuts, of course they will be driving slowly. In the highways, why it's very important is like just like suppose you are traveling in 100 kmph or 120 kmph, like small error in the steering angle which will cause a damage, huge damage to the life of the driver and the environment. So that's the main reason why the overtaking assist systems mainly implemented in the highways. So inside the cities, this condition, I mean, this is not required. But yeah, in the highways, definitely we can implement in the Indian road conditions. So shouldn't that model you showed be in a closed loop, Ruben? Uh, no, Ruben. Here, what we are doing is like the as I mentioned, we are going the baby step, right? So we like initially we are consider 4 inputs. So as you can see from the model, its output will be like it's like okay whether it's a safe overtaking or it's not safe overtaking. So based on that, the driver will respond. Okay, so if the overtaking is safe, then only the driver will steer his steering angle. If it's not safe overtaking, then the driver definitely doesn't steer. The based on what it will be choose is like as you can see, it's like time to collision between the cars and like yeah how the driver takes the controller and how it makes. And of course, it should be a closed loop systems. But yeah, that will take years together to develop. And of course, they are developing the model. And next, Imanshu, how to learn ADAS, like which reference, what basic knowledge is necessary to begin with. I am unsure, as you know, definitely decibels is one of the source. You can definitely learn the ADAS, and the basic knowledge which is required. You should be like knowing the automotive, for example, cruise control. You'll be knowing what is the cruise control. It just follows the vehicles, opposite vehicles. Okay, but to follow in order to follow that opposite vehicle, what is required? Of course the velocity of the opposite vehicle required. So if you have if you some with helping the using the sensors and the GPS data or some other communication, if you grab that the vehicle velocity, then you can just make a control like, okay, if the vehicle well opposite car vehicle velocity is like 70 km, just for it. So these are the basic things which is required. So mainly in the ADAS, as I experienced, the relative distance and the relative velocities and the steering angles. These are the three important parameters which plays in each and every ADAS system. It might be anything, driver park assist, it might be cruise control, lane assist, whatever it is. So we should make a controller in such a way that like these all three parameters included, and like of course the distance. Yeah, so these are the important parameters or the references which will be required to develop the ADAS. So next, guys, I'm just taking the random questions. Okay, please. I mean, I'm not taking the specific questions. Which programming language? It's a question from Mohammed Mudassir. Which programming language is used in this? Can you suggest some programming language for automotive engineering? Yeah, Mohammed. For some automotive engineering, it is like MATLAB is one of the programming language very widely used in the throughout the world, and the other one is like Python. Python, which is basically similar to C programming language. These two languages are basically widely used in the automotive industry at present. So yeah, next question again about the Anand. Road markings are compulsory required for the lane change, right? Yeah, Anand, this is not related to the overtaking system. It's like lane changing system. Yeah, but yeah, it's required, I can say. Yeah. Yeah, Suraj, I think I answered some of the questions. There are like multiple questions. I think, guys, it's better to have to take the course where we can get a better idea about like how we will get the things and all. Maybe Suraj might address that one. Yeah.
Right. Perfect. Um, Prasanna, I think it's fantastic to know a lot of things. I know, as we always discuss, system is very complex. As rightly questioned by few people that what if it doesn't run there? What if some cities the traffic conditions are different? This is like one of the most complex things. That building a system is not a complex thing, but actually making it to work in all the conditions is a more complex thing. That is when, like we talk about, rightly mentioned by you, as a functional safety systems will come into a picture. Very unfortunately, none of our college curriculums just even have the name called functional safety. That's a very unfortunate situation. But guys, you are privileged to attend the webinars like this and get to know just a word. What is functional safety, right? It is one of the very, very important things which we use in the industry terms for every single thing. Okay, there are regulations by ISO on the functional safety. I mean, just remember a word. You can just check it in Google and get to know what is functional safety, because that could be another webinar. We can host it for you to understand. There's a system that we test the system in all the different ways to see the plausible failures. To see the possible failures that system can happen into a place, and rightly drop in by ISO 26262. And apart from it, there are a few more different parts of it for different systems also into a place. So fantastic. I think that was the intention of the program. Is one is to kind of motivate you to understand the possibility and what you can contribute as an engineer. Because if you go to Google and if you see in the internet that there are some small systems you can also develop. You can try to see how best you can make it to Indian situations, maybe jugaad, pricing point of it, which can work with other cars. There are a lot of different things. That's the way we can all get motivated. I mean, if you have the motivation and a passion, everything falls into a place, right? So that's a more interesting thing. And I would, the intention of this webinar is to give you an idea that a system that you can contribute. Imagine 50,000 crores of money is just going wasted because of accidents in India. That's 3% of the GDP. You can contribute something, as an engineer, definitely, right? So Decibels is always there to give you and help and handing support. That whatever we can help in. We're coming up with the course. The course will be in the next weekend. That will be again completely delivered by Prasanna from end to end in terms of the technology till the point of modeling the system. That will be on the weekend as a plan of it. Hi, Prasanna. Hi, Prasanna, is it audible?
Yeah, no, it's audible. Maybe it's my internet connection problem, I guess. Yeah.
Okay, no, actually, it may be my problem too. I'm sorry about it if it was broken out. So, all right, guys, I think that's as an overall, you can always learn with upcoming courses at Decibels. It's pretty much available very soon. That's basically the next weekend. We will have a course for you, and people who are attending the webinars. You'll have a special discount coupon that we will send it to you. You can also take it up and participate. So for this, I believe the webinar was interesting. I believe we have made an effort to give you an idea, give you an overview, bring up small motivation within yourself to start ahead with the things on the automotive side. So with all needs, definitely good engineers are required in the automotive industry. I believe you can be a few of them in the future. So just do let us know, how did you feel about the whole webinar thing? Was it helpful for you, and what is it? Is it giving you some knowledge into a place? I believe if it is yes for you, and I'm quite happy for it. If it is not, just share as a feedback. And I always happy to take that feedback positively and improvise them for the future. So will the course classes be on weekends? Yes, Ashish, we intend to keep them in the weekends, because weekdays we can do 1 hour and call it as a 5-day program, but it just doesn't fit into us because we have ongoing projects at Decibels. Our engineers will be busy, so weekend is the ideal time. We can do the courses. So weekend we will have the upcoming weekend we will have the program. You can definitely take part in it. So fantastic. And the guys who have amazingly stayed back, till the end of the internship, end of the webinar, I'm very happy for you. And there will be a certificate available for this webinar. Okay. We will send you an email to your email ID which you have given in Decibels. You can go there and you can create a certificate. You can share, you can directly add the certificate in the LinkedIn also, as you took part of the webinar in the Decibels, and that helps you also to show your interest, that you're interested in ADAS and systems like that in the professional networks like LinkedIn. You can also do that, so that will be available for you very shortly. I think we will send you the email within a couple of hours for you to get that certificate, and also we'll tell you the procedures to get the certificate. Fantastic. So that's pretty much from my side, and thanks everyone who have taken part in the webinar. To have show your interest to learn the systems and advance yourself basically. Because the systems are not available at universities and colleges, and nobody have an experience either to teach you to this level as a part of it, except the industry people like Prasanna who worked in the systems in your place. So, and also teaching is not just somebody can teach, you need to have a proper way to teach it. And that's where making always interesting with Decibels courses for you. So you can look forward to learn, by the way, and thanks very much for showing the interest. Keep your motive for learning, and keep yourself engaged always about learning technology, and contributing yourself to society and contributing yourself to your country. And with all of that, and thanks a lot, Prasanna, for making your time and all your dedications to make this presentation as a wonderful, informative session. And we look forward to having more and more in the upcoming days for the webinars, and enlighten more students to come into an area of automotive ADAS, and make more lives savable and the country's economy also. And thank you very much with all that note, Prasanna, for making it up. And thank you very much, everybody who have been taking part in this program. And keep yourself motivated. Have a fantastic time ahead, and good night, everyone. Thank you again, Prasanna, for making all this happen. And be in touch, guys. Thank you.
Thank you. Thank you, Suresh. Thank you. Thank you, everyone, for attending this webinar. Thank you, everyone.
Yeah. Thank you very much, Prasanna. Good time ahead.
Thank you.
Thank you. Thank you. Bye, guys. Take care. Safe time and good night. Keep learning. Bye.
Bye, guys. Bye-bye. Good night. Bye-bye.